toward dual-use deterrence on the moon. Commentary. As the United States pursues its goal of sending astronauts to the moon starting in 2028 to start building lunar bases, and China pursues its goal of sending its people to the moon by 2029 or 2030, also to start building lunar bases, it is necessary to consider a lunar political military stability based on dual-use technologies. Concern that China could behave aggressively on the moon is justified based on its behavior on Earth, an unwillingness to recognize the territory of neighboring states while mounting militarized aggrandizement against Japan, Taiwan, the Philippines, and India. This behavior does not bode well for China's willingness to be transparent about its intentions on the moon, while being predisposed to defend claimed areas rather than seeking deconfliction should other countries pursue nearby lunar activities. This becomes more of a concern for two additional reasons. First, both China and the United States are targeting lunar bases for the south pole of the moon due to the greater probability of finding water ice. But as National Aeronautics and Space Administration Moon Base Program Executive Carlos Garcia Galán noted in the agency's March 24 ignition briefing, this region is about the size of the state of Virginia. Second, while Virginia is not a small state, China's early moon landing system will employ two stages, a manned or cargo stage that is decelerated near the moon by a second propulsion stage that detaches and then crashes into the lunar surface. For China, use of the propulsion stage is needed because its initial Long March 10 lunar space launch vehicle can only loft about 26 tons to the moon, thus requiring two Long March 10 launches to put people on the moon. And use of a propulsion stage lowers the weight of the lunar landing system. So far, Chinese state-affiliated sources have revealed that their Lanwen manned lunar lander and a larger pressurized lunar rover will be transported to the moon using the crashing propulsion stage, but it is likely that other payloads will do so as well. For decades, the Chinese regime has tolerated the crashing of SLV first stages into populated areas. So it is a legitimate concern that Beijing will be similarly cavalier about the potential dangers to other countries' lunar settlements posed by crashing Chinese propulsion stages. It is certainly preferable to deconflict lunar basing plans, something that could be done between NASA and Chinese space officials who attend the annual International Astronautical Congress, which brings together space officials and engineers. But China's decades-long refusal to consider transparency and controls over its nuclear weapons does not bode well for its willingness to ensure that other countries are not bombed by its 5 to 8-ton moon-crashing propulsion stages. As such, it is necessary to have a backup plan that can deter China from aggressive behavior on the moon and to defend against potentially dangerous behaviors, such as refusing to prevent threats from its moon-based propulsion stages. By now, it's also possible to discern that both the United States and China are preparing to deploy dual-use systems to the moon that could serve defensive military objectives, offering the possibility of a system of lunar deterrence. Lunar satellites. Both the United States and China plan to deploy small constellations of satellites around the moon for surveillance of the lunar surface and to enable lunar navigation and intralunar and Earth-Moon communication. Since 2024, China has deployed its Ke-Chiao 2 communication relay satellite to the far side of the moon, supported by 2 small Tiandu navigation communication development satellites. By 2050, China intends that Ke-Chiao will host a large number of communication, surveillance, and navigation satellites, enabling missions to the Moon, Venus, and Mars, and even further into the solar system. NASA intends to deploy 2 groups of 5 lunar satellites in 2027 and 2028 to perform surveillance, navigation, and communication missions. Both China and the United States could use their lunar satellite constellations to support military objectives on the moon, and both are developing combat satellites for low Earth orbit operations, which, if needed, could also be deployed to lunar orbits. Moonhoppers. For its next change, 7 unmanned moon probe mission later this year to the far side of the moon, China will test a small moonhopper, an unmanned vehicle able to fly or hop into a nearby moon crater to search for water ice. On March 24th, NASA revealed that it intends to deploy 3 groups of 4 hopping vehicles to the moon in 2028, 2030, and 2032, a total of 12 such vehicles. Even early, Small hopping vehicles like China's could swap out their small science payload for a small electromagnetic pulse grenade that could disable unshielded electronics at the target moon base. The fact that both could use their hopping vehicles as Earth-bound unmanned combat aerial vehicles would add to deterrence. Lunar nuclear power. On March 24th, NASA revealed its intention to develop space nuclear thermal power systems to propel a nuclear thermal-powered spacecraft to Mars in 2028, with that power system also serving as the basis for a lunar-based nuclear power system for U.S. bases on the Moon, to compensate for the loss of solar power during the lunar night. Co-developed with the U.S. Department of Energy, the plan is to deploy a 40 to 100 kilowatt fission power system to the Moon by 2030 or 2031 to provide reliable power for U.S. unmanned and manned moon-based systems. Chinese literature also reveals the intention to develop space nuclear power, both to propel spacecraft into deep space and to generate electricity for Chinese lunar bases, with a prototype space reactor reported to have been completed in 2023. As fear of retaliation is the basis for nuclear deterrence on Earth, there would be a similar fear of retaliation that would deter attacks against lunar nuclear power stations, which would threaten personnel and contaminate a lunar base, thus preventing recovery and rebuilding. But as a lunar nuclear power station would power lunar habitats and lunar rovers, it could also power future lunar mining lasers, which may also be inherently dual-use and early lunar artillery. With the May 4th signature of Ireland and Malta, there are now 66 nations that have signed the 2020 Artemis Accords Principles for Transparent and Peaceful Behavior on the Moon, which form the basis for future U.S. cooperation on the Moon with all Artemis partners. As the leader of the Artemis coalition, the United States should try to achieve lunar deconfliction with China, especially to prevent errant Chinese propulsion modules from posing a threat to Artemis coalition lunar activities. However, inasmuch as the Chinese Communist Party may regard dominance on the Moon as a necessary tool for achieving future hegemony on Earth, the United States may have to lead its Artemis partners in making sure that dual-use technologies are deployed in a way that creates a system of lunar deterrence.